Alright, Calc students, yesterday when I was making the study guide videos and I did problem number 8 from the non-calculator section of the test, I told you just to do it on the calculator, but here's the deal. You should be able to do these problems without a calculator because really it comes down to skills that we've already practiced and worked on. So what I'm going to do is I'm going to modify problem number 8, give you a slightly different one with prettier numbers so that you can do it confidently without a calculator. So remind yourselves that we are dealing with a problem. Some object is thrown straight up into the air with an initial velocity from an initial height, and we want to calculate 3 questions. We want to know what's its max height, when is the velocity 0, and when is it going to hit the ground. So our function was s of t equals, originally it was negative 4.9 because we were dealing in meters. I'm going to give you this problem in feet, which I'll say is negative 16 t squared plus v naught t plus s naught in this case because our function is s of t. It means the same exact thing as h of t. It doesn't matter what variable is used. This is the position function. So I'm going to tell you that I threw an object up into the air with an initial velocity of 64 feet per second, and I threw it from a height of 80 feet because I was standing on top of a really tall ladder. So plug those numbers in to write your equation. S of t equals negative 16 t squared plus v naught t. V naught is 64 t plus our initial height of 80. Now, in order to answer these questions, questions B and C can both be answered by completing the square. And I'm actually going to answer those before I answer question A, because completing the square will also be nice for answering question A. So basically what I'm saying is complete the square. In order to do that, recall back to our factoring unit. Factor out negative 16 from your t squared term and your t term. So pull out that negative 16. What are you left with? You're left with t squared, and then 64 divided by negative 16 is going to be negative 4t. And I don't actually have to do anything with that 80. I can just leave it there because I'm going to have to add or subtract when I complete the square anyways. So now I want to look inside there and complete the square on t squared minus 4t. So I'm going to just write everything else down as I have it. S of t equals negative 16. That's still there. And to complete this square, again, all you have to do is take half of that t term. So I'm going to end up with t, half of negative 4 is negative 2 squared plus 80. This is where you got to remember, to complete the square, I'm going to end up with this negative 2 times itself, negative 2, which is going to be positive 4. So that's like inside the parentheses. I had to add 4 to complete the square. So normally you would have to subtract 4 to balance your equation out, but everything in there is being multiplied by negative 16. So that positive 4 I had to add to complete the square is really like 4 times negative 16, which is negative 64. So to balance my equation, I actually have to add 64. Holy moly. If you don't remember how to do that, you should come and talk to me about completing the square, or watch any internet video on completing the square, because there are so many of them. But let's go ahead and simplify all this mess. S of t equals negative 16 times t minus 2 squared plus 80 plus 64 is plus 144. That's sweet. Now we can start answering questions. So question A says, when's the object going to hit the ground? Well, this is a position function, so that object's going to hit the ground when the position is 0. So go ahead and say 0 equals negative 16 times t minus 2 squared plus 144, and just use your algebra skills to solve for t. So subtract 144 from both sides. Negative 144 equals negative 16 t minus 2 squared. Now divide both sides by negative 16. Negative 144 divided by negative 16, well, that's the same as 144 divided by 16, which again, you can use long division for, but it's kind of pointless and it kind of sucks. So what I do when I do this problem in my head, I'm just going to try and multiply numbers by 16 to see what gets me close to 144. Hopefully it'll be an even number. So the first number that pops into my head is 10. 16 times 10 is 160. Well, I'm a little bit over 144, but I'm pretty close, so let's try 16 times 9. 9 times 6 is 54. How does math work again? Oh yeah, 9 times 6 is 54. Put that 5 up there. 9 times 1 is 9, plus 5 is 14. So hey look, 9 goes evenly. So the whole point of that again was to get 144 divided by 16 is 9 equals t minus 2 squared. So now go ahead and square root both sides to get plus or minus 3 equals t minus 2. And then we're going to get the equations 3 equals t minus 2 and negative 3 equals t minus 2. Solve both of those to find t equals 5 and negative 1. And in the context of the problem, the only answer that makes sense is 5, because I don't really know what it means for time to be negative. So that's my answer. I'm sticking with it. So A, when does the object hit the ground? The object hits the ground after t equals 5 seconds. Next question is super sweet because I don't remember which one asks which, but I think B asks, when is the velocity 0? Well, the velocity is going to be 0 when the original function has its maximum value, because remember, the derivative of position function is in fact velocity, and the velocity, and remember, derivative is the slope of our function. The slope of that function is going to be where it transitions from increasing to decreasing at our maximum value right there. Our slope's going to be 0. So go ahead and figure out what is the x value that makes that 0. Well, hey look, we completed the square because we're awesome, and we have the function right here. And again, completing the square is sweet because we can look at that and say, oh, okay, well, this function is going to have its max when x equals 2. So the answer to B, when is this velocity 0, is the velocity of our function t equals 0 when t equals 2. Next question, what is the maximum height of the object? Well, hey look, again, vertex form is the sweetest thing ever. Our maximum height is that k value right there. Can you see it? I circled it. It's 144. So we would say that the object reaches its maximum height of 144. And we're done. And we did it without a calculator because we're super smart and we're super awesome and we're gonna get a really good score.